Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSC, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. This is my 41st video lecture on the course Applied Artificial Intelligence. Today I am going to discuss about the topic Planning Uncertain Movements in Robotics. In my previous video already I have introduced regarding the introduction to robotics and the robot, different types of robots, robot hardware, planning to move, how robot plans to perform the movement, and today I am going to discuss about planning uncertain movements in robotics. If the situation is uncertain, how the robot should plan. These are the topics to be discussed. First, I will discuss what is the meaning of uncertainty in robotics, the nature of uncertainty in robotics, then why the perfect wall or the deterministic planning fails, then to overcome the problem of deterministic planning by the robot, probabilistic approaches are used to handle uncertainty. So two different approaches are there. One is Markov Decision Process, that is called as MDP, and partially observable MDP, that is POMDP. These two are the probabilistic approaches to handle the uncertainty in robotics. And compared to the probabilistic approach, one more advanced technique is there, that is robust control method, which is nothing but the worst case planning. And the final one compared to probabilistic and the robust control method, that is fine motion planning or FMP. So all these probabilistic approach, robust control methods and fine motion planning, all these methods are used to handle uncertainty in robotics. This is the topic learning outcome. After the completion of this topic, students can analyze the limitations of the deterministic planning and formulate simple MDP problems. MDP stands for Markov Decision Process problems for robotic tasks with full state observability. Okay, let me discuss about the nature of uncertainty in robotics. Why this uncertainty happens? Why robots face the uncertainty? If we talk about the normal robot or the toy robot or talking robot, which is used by the kids, or the robots which are used in the industries or in the logistic, all uses the deterministic type of plan, where the actions are already confirmed, and based upon the confirmed configuration, accordingly the robot behaves, or accordingly the robot makes a plan for its movement. But all the situations are not deterministic. If the undeterministic situation, sometimes it happens in case of the disasters, or in case of the rescue, or in case of the exploring the undersea exploration, even in the industries also, some uncertainty situation happens. So to handle that uncertainty, this robots needs to plan how the movement should be performed. So robots do not have the perfect senses or the movements every time. So because there are three main problems of the uncertainty. One is the partial observability, second one is the stochastic actions, and third one is approximation errors. The partial observability, it is also called as the sensor limitations or bad senses. Stochastic actions are also called as unpredictable movement effects, and approximation errors are called as math is not perfect. I will explain all these terms with the help of examples so that we can understand. The first one is partial observability or sensor limitations or bad sensors. The meaning of partial observability, which is partially visible. These two words, partial observability means half visible, not completely visible. That means the sensor of the robot cannot accept or cannot provide the complete information about its surroundings. So sensors provide incomplete or the noisy data about the world. Here noisy data means it's not like the loud voice, it is about the half information or incomplete information, we can say. So whenever sensor provides incomplete information that is called as the noisy data about its environment. For example, when this incomplete information happens, if you take the example of the self-driving car and the car is driving suppose in the foggy environment, then the camera of the self-driving car may not receive all the obstacles which is nearby to the car because of this fog. So that is called as incomplete information received by the sensor of the self-driving car. So if it is noisy data or incomplete information, definitely the robot cannot take proper decision. Then what will happen? The crash may happen. So the problem is here, if sensor gives the wrong or noisy data, the robot may crash. That is one of the problem of uncertainty, which is called as partial observability. Second one is the stochastic actions. It is also called as unpredictable movement effects. Unpredictable movement effects means, for example, whenever we are going from our home to the college, so while going, it's not like every time it is confirmed that I will reach the college. So while going, some uncertain situation may happen with us. Either the wheel of the bus may puncture or some traffic jam may happen. So because of that, I may reach late. Same thing happens with the robot also. So robot's movement may not always produce the exact expected outcome. That means because of the wheel slippage or broken or the any damage of the parts damaged of the robot. So in that case, robot cannot perform the exact movement or cannot give the expected outcome. So for example, here I have given a drone trying to hover gets pushed by the wind. That means whenever suppose a drone is trying to stay stationary at a particular place, but what happens because of the force of the wind from opposite direction, the drone cannot stay as stationary at that particular moment. It may move forward. So, but drones like goal is to stay stationary at that particular time for a period of 5 minutes or 2 minutes, but which was not possible because of the wind pressure. So this type of situations are called as uncertain situations or stochastic actions, which is unpredictable movement effects. So here what will happen? The problem, even if the robot plans well, real world physics like slippery of the floor or air resistance mess up the execution. That is what in real life with the robot also it happens. Now the third one is the approximation error, which is also called as math is not perfect. So what is the meaning of this one? Approximation error, some exact value is there and approximate value is there. If there is some mismatch or any difference is there, then we can say there is a deviation between the exact value and the estimated value. So state estimation techniques, for example, the particle filters introduce the errors due to discretization or noise. For example, a robotic vacuum cleaner uses a grid-based map like a chessboard to navigate your home. In my previous video, I discussed about the planning for move, then the whole environment. Two things I discussed in my previous video. One is the workspace. Another one is C space, configuration space. C space means the configuration space. Workspace is nothing but the physical space where the robot is present. But configuration space means the whole space which will be covered by the robot will be configured inside it. Means with the help of software, all the hardware parts of the robot will be configured using the C space. That is called as configuration space. Suppose, for example, your complete home, it may be 1200 square feet or it may be 2000 square feet. The whole area of your home will be configured in the sensors, effectors, even all the hardware of the robots. So that space is called as configuration space. Basically, the configuration space is created with the help of grids, like with the help of rows and columns, how the pixels are visible to visualize clear picture on the screen. The same thing, the configuration space will be created with the help of grids, and each grid will be labeled as either free or it is occupied. Wherever the free spaces are there, those free spaces will be connected, and that will be considered as the correct path for the robot. The same thing here. So whenever the robot uses the configuration space, now you can see the problem here. The robot rounds its position to the nearest grid square. The real position is this one. This is the coordinate of the real position of an object, and the estimated position is showing this one, 1.2 and 3.8, whereas the real position is 1.23 meter and 3.78. And so what is the error now? If you find the difference between these two, error is somewhat 3 to 8 centimeter per step. So robotic vacuum cleaner, whenever it is first time configured and it is not, if suppose it is not configured properly and we are giving some other location of the position of the obstacle, in that case what happens, it may produce the estimated error, which is called as approximate error. So if that type of error is generated, then robotic vacuum cleaner may hit to some other wall or some obstacles, and it may not clean the floor properly. That would be the problem. So that type of problem is called as the approximation errors, or math is not perfect. So the result is the vacuum misses the dirty spot or bumps into furniture. It though through was farther away. Okay, so that is the situation. I hope you might have understood what is approximation error, all the three techniques, why all the uncertainty happens because of the partial observability or the noisy information or the bad senses, stochastic action, uncertain movements, uncertain action, and the approximation error. Approximation error, which is called as math is not perfect. Now let us discuss why uncertainty matters to the robot. Is it very important for the robot? Is it accountable for the robot? Yes, of course, robot has to take care of this uncertainty. Otherwise, in every situation, robot may not work properly. So if the robot ignores these uncertain situations, then what will happen? Robot may crash, or it may hit to the wall, or it get lost, or it fails the task. So implications are robot must account for uncertainty to avoid this type of failure. Failure means either collision with the wall or collision with the obstacle or missed goals. Even if you can take the example of the self-driving car, all possible cases of probability should be taken care by the sensors. That means these probabilities conditions, theoretically I am telling you, but all these conditions will be configured inside the hardware. So, and sometimes what happens, the deterministic planning. Normally deterministic planning, where the configuration is fixed forever and never it is going to be changed, then in that case it is possible. Okay, deterministic planning can work. But in case of the drone, or in case of the robot, whenever it works in the hospital, or when it works in the outside or in the mining area, in some other situation, in that case it will be very difficult to handle the uncertain situations. So that is why uncertainty is very important and it should be taken care by the robot. Now, why the perfect world or the deterministic planning fails? Most of the robot uses the deterministic planning, assuming everything is perfect. As I told, deterministic planning means already the configuration is fixed. This much fixed distance the robot will travel from one position to another position, and it is not going to be changed, and the position of the obstacles are also fixed. So in that case robot will work accordingly. So how the deterministic plan occurs, like these are the three steps here I have mentioned. Take the most likely sensor reading, like I am probably at XY. Plan a path assuming that there is no error, and replan if something goes wrong. That means, so for example, when robotic vacuum cleaner is cleaning our house, if any obstacle comes into the picture or it comes in front of the robot, then robot it will not hit to that obstacle. It may take some other decision, and it may take some other route to move in another way, and it tries to clean the whole floor. So that is called as the deterministic planning. Now, what is the problem with the deterministic planning? Where it fails? So normally, even though robots are configured with the deterministic movement or deterministic plan, but it fails under high uncertainty. If the environment changes unpredictably, or replanning may not be very fast. That means in the dynamic situation or the environment is going to be changed very frequently. Like whenever we are sending one drone to a disaster environment, in that case, the wind force may be very high, or some other pressure some other pressure may come into the picture, or some other drone comes near to the active drone. In that case, in that uncertain situation, then robot has to take the decision for its movement or for its further work, as well as the suboptimal or dangerous behavior. That means it can lead to collision or failure to reach the goal. Now you can see the example in warehouse robot. A warehouse robot plans a straight path, but a box falls in its way. Now in the warehouse, where like warehouse means where the contents or it is a house, we can say, where the materials are stored from different departments for a longer period of time. That is called as the warehouse, or a big factory, we can say, where the robot plans a straight path. But while during the movement of the robot, suppose a box fall on its way, which is called as unexpected obstacle. So in that case, or else we can say that if the box falls in front of the robot, that is called as unexpected obstacle. And suppose the wheel slips on the oil, that is called as the movement error, and it thinks it is 10 centimeter left on its real position, that is called as the estimation error, which is called as math is not perfect. So all these are called as the uncertain situations. So uncertain situations should be taken care by the robot. Now, to handle this uncertainty, one of the important method is called as probabilistic approach to uncertainty, or probabilistic approaches to uncertainty. So instead of assuming one correct state or the deterministic state, here robot can use the probabilities. So there are two probabilistic approaches to uncertainty. One is the Markov Decision Process, which is called as MDP, and second one is the partially observable MDP or POMDP. Now we'll see. Mathematically, I will not discuss because this is that much not important, but we should know how this Markov decision process takes care of the robot's movement, and how this POMDP also overcome the problem which occurs in the MDP process. So first one is the Markov decision process. It can handle the motion uncertainty even with the perfect sensing also. Even though the robot is planned with a deterministic actions, still it can handle uncertainty using MDP process. So even if a robot knows its exact location right now, which is called as deterministic, its next state of action may uncertain because of some problem, because of maybe wheel slippage, or because of uneven retrain, or because of wind or water current for drones or underwater robot. So such type of uncertainties can be handled by MDP method. Now what MDP thinks, this process, Markov decision process, thinks in what way? For example, I have shown one example. A delivery robot knows it's at position at XY, means the delivery robot is present in the two-dimensional space whose coordinate is X and Y, but it is not sure if its next move will take it exactly 1 meter forward because of the floor friction. So in that case, what MDP plans for the probabilistic outcome? So this is the statement, I hope you can understand. If I move forward, this is the statement which is taken care by the MDP process, not the deterministic process. So MDP plans like this: if I move forward, so there is a 90% chance I will reach the target, means I will reach the destination, and 10% chance I will be left. So this type of probabilistic actions will be taken care by the MDP. Theoretically, we have written like this: if condition, and the same condition will be implemented with the help of programming whenever the sensor has to receive all this information right from the environment. So sensor will be configured with if-else statement using some programming language. So but this is the plan will be taken care by the MDP process. So one of the important point here I want to tell you, MDPs do not assume the perfect control, means the deterministic actions, just perfect state of observation. A probabilistic state of action, it takes care. Now The second one is the partially observable MDP or POMDP. So POMDPs are called as partially observable Markov Decision Processes, which are computationally, they are very much expensive compared to MDP process, but they are essential for the robots working in the real world uncertainty. Especially these POMDP processes are used in the real world action, like in the drone, or the like for the drone or the robots which work in the underwater exploration, or the robot which moves to the space. So in that real life situation, these POMDP methods are used. So unlike MDP, which assume the perfect knowledge, POMDP models sensor limited. What are the limitations for POMDPs? Like camera can miss the object, or leader gets noisy in the fog or rain, or odometry dips over time. So these kind of uncertain situations can be taken care by the POMDP method. Now you can see the example, the self-driving car I have given here. For the self-driving car, what statement MDP process takes or assumes, and what step POMDP process assumes. Like if you take the example of self-driving car, an MDP would assume I am exactly 3 meter from the intersection. Means I am the robot or the machine is exactly 3 meter away from the obstacle. But POMDP method says that I am probably 3 to 3.5 meter away, but could be farther. This kind of very good probabilistic statement compared to the MDP method it produces. So based on that, again, but these are theoretical statements. The statements will be configured with the help of programming language for the particular sensors or end effectors for their action. So result will what happen? The car slows down early, avoiding a potential red light run. That means what we have understood from this example, if we use both the method, the Markov decision process and probability Markov partially observable MDP process. So using POMDP method, the robot can take care before it collides. Okay, so that is what the result here. The car slows down early, avoiding a potential red light run. Automatically it takes care before its collision. But here in case of the MDP method, it sometimes the collision may happen also, because it considers the deterministic plan as well as the probabilistic plan, whereas POMDP does not consider any deterministic plan. It considers only probabilistic, and in this way, as I have given this example, so precautionary measure will be taken care by the machine itself before it collides. That is what is called as partially observable MDP method. Now, POMDP can actively reduce the uncertainty. One more example here I have given, search and rescue robot. The robots which are used in the disaster environments, like the place where the earthquake happens. In that case also, the robots are configured with the MDP process or POMDP method, because all the situations should be probabilistic. So if MDP method work, then it says move straight to the target. It may get stuck if path is blocked. But POMDP, what it states, it first if POMDP method is used or it is configured in the robot or in the machine, then what it will do, before giving any statement, first it will try to explore all the uncertain areas. If it is free, or then only the robot will try to move. Otherwise, it will take the right decision at the right time. So first, whenever it explores first the uncertain areas, then it will try to find out, is that a victim or it is just debris. So like this type of situation can be taken care by POMDP method. So if you compare MDP and POMDP, definitely POMDP would be the better one compared to MDP. Now, when should we use this POMDP method, partially observable MDP method, Markov Decision Process? So as I told, this POMDP and both MDP, they are used in the real life situations, like whenever the sensors are noisy, Noisy means the sensor does not make noise. If the sensor receives the incomplete or partial data, partial observable data, in that case we can say sensors are noisy. Especially in case of the drones or underwater robots, sensor may not receive the complete information about its surroundings. And whenever the environment is dynamic, means continuously changing environment. Now if you consider the weather condition, now it may be sunny, after 5 minutes it may be rainy or it may be cloudy. So that is called as changing environment. So like even if you can take the example of the self-driving car, when self-driving car moves on the road, all the situations would be like the situations are dynamic situation. It may find the pedestrian, it may find the obstacle, it may find the animal on the road. So suddenly something may happen at any point of time. That type of situation is called as dynamic environment. So whenever sensors are noisy, environment is dynamic. And the third one is the task require information gathering. Whenever the task which requires the information gathering, means in case of the search rescue process, at that time the robot has to find out where whether that object is a human being or whether it is a normal object. So that kind of search and exploration is continued. So in that case also the situation would be dynamic. And one more thing, the safety is critical. That means whenever the situation is more dangerous, especially in the medical industry, surgery or autonomous weapon, in the nuclear bomb explosion or nuclear disposal, removal of nuclear disposals. So in that case, these robots, these POMDP methods can be used. Now, now when we have to avoid this type of POMDP methods, and we should not use whenever there is no uncertainty or low uncertainty, especially the factory robots which are fixed, which are constant at a particular place, and they can move their mechanical arm to grip the object or to hold the object or tight the screw, or the similar kind of actions they can perform repeatedly. So in that case, uncertain situation, it may not happen. So then we can avoid these POMDP methods because it is very costly and it is expensive. So, and extremely fast decision needed, like the drone racing. Wherever the fast decision is taken care, like you can take the example of the metro train, you can take the example of the drone also. In that case, these POMDP methods cannot be used. It should be avoided. Now, compared to this probabilistic method, as I discussed both this MDP method and POMDP method, one more advanced method is there compared to this probabilistic method, that is called as robust control method, which is also called as worst case planning. Worst case planning means at the worst case situation also robot can work. That is the meaning of robust control method, which is robust compared to other methods. So robust control method is like the planning for the worst case scenario. It ensures a robot will still work even if things go wrong. So some robots cannot afford to the guess, like safety critical systems. In medical robot, autonomous cars and nuclear plant robots, a single mistake can be catastrophic. Means if any mistake happen for a fraction of second also, some uncertain situation may happen which cannot be recoverable. But now you can see the example here, the surgical robot. If we use the POMDP method, then what the POMDP method will be, how this POMDP method can be applied for the surgical robot, like there is a 5% chance I am cutting the wrong tissue. But in case of the robot control method, never cut unless you are 100% sure. So this kind of situation, this kind of actions will be taken care by the robot control methods, or which is also called as worst case planning. That means what is the difference between POMDP and robust control? In POMDP, still some 2% or 5% chances would be there for failure. But in case of the robust control, there will be unless and until the sensors are not 100% sure, that till that time they will not start the work also. First they will get the confirmation, then only they will start their work. That is called as robust control method. So robot control methods, or which is called as the worst case planning method, they can work even when the sensors fail completely. POMDP and MDP rely on the sensors feedback. Based upon the sensors feedback, these two methods they work. But this robust control method, they do not depend upon the sensors feedback. They take their own decision. So robot control method can still the function blindly. That is why the term, this is one of the important term, conformant planning. As the robot control method, it can work even if the things goes wrong. Then this type of situation is called as conformant planning. I think you might have studied in operating system. One of the important term is fault tolerance. Whenever all the systems, even there is one system fails, then other system, what happens? Other system, they take over the failure systems jobs, and the jobs will continue. The process never stops. Same thing here. The robot control system, they can work even if anything fails or if anything goes wrong. So that is called as conformant planning. So conformant planning means works without any state of information. Now you can see the example. A robotic arm or the mechanical arm picks up an object blindly but ensures it won't hit anything. So that kind of things can be taken care by this robot control method. Now, compared to the robust control method, this is the final one I want to explain you here. Fine tuning method and fine motion planning, FMP, which is especially it is used for high precision tasks. It is used in high precision tasks. Then what is the meaning of high precision tasks, like the robotic assembly or peg-in hole insertion, which is very critical actually. Assembling all the parts of the robot, that is called as high precision. It takes more time, more price, more expensive, more resources. That is called as high precision, and which should be fully accurate. So in that case, this type of we cannot go for probabilistic method. Even we cannot go for the robust method. We can go for fine motion planning or FMP method. But what is the problem? What are the challenges in FMP? Sometimes the sensor inaccuracy, small errors in position sensing, environment uncertainty, except shape or positions may not be known at small scales. Then these are the problems with this FMP actually. So one of the important method in this methodology, it is used fine motion planning, that is called as guided motion. So here the strategy, the strategy which is used in this fine motion planning, that is called as guided motion, to handle the uncertainty. Here motion commands are used to execute the planned movement, and termination conditions are also used to stop based on the sensor's feedback. So these two things are configured for the hardware of the robot when we are using the fine motion planning for high precision tasks. Now you can see the example here, the peg-in hole insertion. This is one of the high precision tasks, which is very critical task to insert the peg inside the hole. So step 1, how the robot will do or machine will do. These are the steps will be followed by the machine. Move peg near the hole, may be misaligned. Step 2, slide along the edge, compliant motion. And step 3, when force spikes, peg hit the bottom and stop the process. So this is the way, the overall summary of this fine motion planning, especially it is used when the task is highly precision. I hope you might have understood all these topics